everyone, I am Ramya, Assistant Professor from the Department of Computer Science and Engineering, St. Joseph's Institute of Technology. So today I am going to handle about one of the most interested and important topic called as software engineering. So if we take software engineering, basically it can be divided into two parts. One is software, the other one is engineering. So what is meant by software is nothing but it is a collection of program. And then what is meant by engineering means it is an application of scientific and practical knowledge. So together what we call software engineering is a collection of program that is used for creating scientific and practical knowledge applications. So this is called as software engineering. And next we shall see the need of software engineering. There are various needs in software engineering. Now let us see some of the needs in software engineering. Okay, so the needs are handling big projects, minimize the cost, decrease time, reliable software, effectiveness, and then reduced complexity. So first let us see one by one. Number one is handling big projects. So if we consider the projects that are done in Reserve Bank of India or State Bank of India, so those projects are very big projects. So this software engineering is used for creating those big projects that are needed by various banking companies. Next one is minimize the cost. So minimize the cost means all the user should be able to access the software at a lower price. So that is one of the need, that is the next need for software engineering. And the third one is decrease time. For example, if we consider the airline ticket booking or train ticket booking, so the booking should not take more amount of time. The booking should be done in a lesser amount of time. So that is the next need, it is decrease in time. Next one is reliable software. So that will be the fourth one, reliable software. So what happens here is while creating a software or while developing the software should be given to the customer or produced to the customer at the right time without any defect. So that is called as a reliable software, and that is one of the need for software engineering. And the next one is effectiveness. So whatever software you are creating, so that should contain good accuracy and then it should provide the security. So that is the next need. And the next one is reduced complexity. So the software while creating, the software should be very simple so that everyone can be able to use the software, and then easy to use. So if it is simple means obviously it will be easy for all the customers or users to use the software. So these are all the need for software engineering. Okay, next we shall see about the characteristics of good software. So the characteristics can be classified into three categories. Number one is operational, number two is transitional, and then number three is maintenance. So let us see what all comes under the operational, transitional, and then maintenance category. Okay, first if we consider about the operational category, so what all comes under operational is budget, efficiency, usability, dependability, correctiveness, functionality, safety, and then security. So all these things comes under the operational category. Next if we see the transitional category, so under transitional category, interoperability, reusability, portability, and then adaptability. So all these things comes under the transitional category. And the third one is maintenance. So under maintenance what all comes is flexibility, maintenance, modularity, and then scalability. So all these things comes under the maintenance category. Now let us see one by one. First one is budget. So when you are creating a software, the software should be in the right budget. It should not take more cost. The cost for creating the software should be in a range. It should not take more cost. So that is called as the budget. So in such way you have to create the software. Next one is efficiency. So while creating the software, you should think that it should achieve its goal. For what purpose you are creating the software, that purpose has to be satisfied. So that one is called as the efficiency. Next one is usability. So when you are creating the software should be easy to use, so that everyone, the students, whoever working with that software should be able to use that software very easily. That is called as usability. Next one is dependability. So what is meant by dependability is, while creating the software, it should not depend on more factors. So that is called as dependability. Next one is correctness. So this is one of the important characteristics. So while creating the software should create the right and correct result. So that is called as correctness. Next one is functionality. So when a software is created, it should contains all the features and functions. So that is called as functionality, and these two things are the most important. One is safety and the next one is security. So while creating the software, it should contain all the safety features and measures. So in such way the software has to be created, and this is the next one is security. This is also one of the most important feature. The software should be secured. So these are about the operational characteristics in software engineering. And the next, let us see about the transitional characteristics. And here number one is interoperability. So what is meant by interoperability is, it is nothing but exchange of information. So when you exchange the information between the softwares, the information should be exchanged without any defect or loss. So that property has to be achieved in case of software engineering. And then reusability. So the software which you are creating should be used again and again. So after you can make some modifications and you can able to reuse the software. In such way it has to be created. So that is the next characteristics, reusability. Next one is portability. So while creating the software, it should have portability feature. So that means you should be able to run the software in all the platforms, like you should able to run the software in Windows, or you should be able to run the software in Linux or in Mac OS. Like that you should be able to execute or run the software in many platforms. So that is called as portability. And next one is adaptability. So the software what you are creating should be adaptable to all the environments. So these are all these are the features that comes under the transitional characteristics. And the next one is maintenance. So under maintenance, the first one is flexibility. The software which you are creating should be flexible to all the users for using it. So that is flexibility. The next one is maintainability. So the process of maintaining the software should be easy. So that is called as maintainability. Next one is modularity. So modularity is nothing but, so while creating the software, you will be breaking down into various modules. So like that, if you break down the softwares into various modules and then if you create, so that concept is called as the modularity. Next one is scalability. Scalability is nothing but, so even though if the number of users who are accessing the software gets increased, the software should perform well. So that is called as the scalability feature of software engineering. So overall, these are all the characteristics of a good software. So whatever software you are creating, that should contain all these characteristics. In such way you have to create the software. Next we shall see about the nature of software. So the nature of software can be classified into all these types. So let us see one by one. System software, application software, engineering and scientific software, embedded software, web application software, and the last one is artificial intelligence software. First one is system software. So the software that provide platform for other softwares are called as system software. For example, Android, Windows, Linux, Mac OS. So these are some of the examples of system software. Android Windows, Linux and then Mac OS. So all these softwares will provide platform for other softwares to get executed. So these are called as system software. Next one is application software. So what is meant by application software is the software that is used to carry out specific tasks as per user and business need. So this type of softwares are called as the application software. For example, PowerPoint, Excel or spreadsheet, word processing, web browsers, gaming applications, etc. So these are some of the examples of application software: PowerPoint, Excel or spreadsheet, word processing, web browser and then gaming applications. So these softwares carry out a specific task as per the user and business need. So that is why these softwares are called as the application softwares. The next one is engineering and scientific software. So the software that is used to handle the real-time data. So those softwares are called as the engineering and application software. For example, stock market, weather forecasting, so these are some of the examples of engineering and scientific software. Stock market, the software that is involved in stock market and weather forecasting, so they will be used to handle real time data. So these are called as the engineering and scientific software. The next one is embedded software. So the software that is related to related in creating hardware applications. So those softwares are called as the embedded software. For example, so the software that is involved in traffic lights. So that is an example for embedded software. And then the software that are used in washing machine or in digital camera. So those softwares are called as the embedded softwares. So the next example is washing machine, digital camera, so traffic light, the software that are used in traffic light, washing machines, digital camera. So all these are examples for embedded software. The next one is web application software. So what is meant by web application software is the software that is involved in client server programs that runs on the web browsers. So those things are called as the web application software. Example, Google, then Yahoo, and then the softwares that is used in shopping carts. So those one also we can take as the example for web application software, shopping carts. The next one is artificial intelligence software. So the software that uses non-numerical algorithm to solve complex problems. So those software are called as the artificial intelligence software. For example, Google Cloud, TensorFlow, Azure Studio, So these are some of the examples for artificial intelligence software. Okay, now let us see the models of software engineering, models that are used in software engineering. First, let us see about the waterfall model. So waterfall model consists of requirement, design, development, testing, deployment, and then maintenance. So what happens in case of requirement is, so the requirement of the customer is got. So whatever is the requirement of the customer, those requirement are received, and after receiving the requirement, designing happens. So designing is nothing but it is the structural representation. So after getting the requirement from the customer, the designing part is done, that is creating the diagrammatic format based on the requirement, the diagrammatic representation of what is going to be done. So that is done in the design part. So after completing the design part, the next phase is the development. So here what happens is the coding is done. In case of development, so the coding activities are done, and after completing the coding activities, testing is done. So whether the coding that is created, so those codings are working correctly or not. So all these things are done in the part of testing. And then after the testing, deployment. So deployment, what happens in deployment is, so whatever you have created, so that one is given to the customer. So giving the prepared software or developed software to the customer, so that is called as the deployment. And after the deployment, the last phase is going to be the maintenance phase. So in maintenance phase, what happens is, so if there are any feedback from the customer, so based on the customer's feedback, the necessary changes are made in the software, and then again it is provided to the customer. So these are all the phases in waterfall model. So let me say once again, so first, based on the customer requirement, the design is created, and after creating the design, so it is nothing but the structural representation, and after creating the design part, development activities are done. So here coding is done, and after creating the coding, testing is done. So here whether the software is working correctly or not, or the code which the user created is working correctly or not. So that one is tested, and after doing the testing, the software is delivered to the customer, and if the customer has any maintenance issue, the maintenance issue is solved, and then again it is provided to the customer. So this happens in case of the waterfall model. So features, so here the waterfall model has some features. The first one is the fixed requirement. So whatever requirement that is given at the beginning, so those requirements are fixed. So you cannot make any changes in the requirement. Next one is used in small projects. So this waterfall model, this is the basic model. So this can be used only in small projects, and it cannot be used in very big projects. And the next one is low cost. So since it is small projects, obviously the cost will be very low in case of the waterfall model, so that everyone can be able to access this waterfall model. So the documentation also very good in case of the waterfall model. But it has some disadvantages. So the disadvantages are high risk, low customer involvement, and then difficult to recognize error. So these are some of the disadvantages in waterfall model. So the next model what we are going to see is iterative model. So here what happens is we have many iterations, iteration 1, iteration 2, iteration 3. So we have many iterations, so that is why mainly it is called as a iterative model. Previously we have seen about the waterfall model, there we don't have this many iterations, we have only a single iteration. But here in case of iterative model, we have many iterations. So let us see about those iterations. First one is requirement. So whatever is the need of the customer, so that those requirements are got from the customer, and after getting all the requirements, analysis is done based on the requirements. So everything is analyzed in case of analysis phase, and after doing the analysis, designing is done. So after doing the analysis, creating a structural format, the diagrammatic format is created in case of the design design part, and after doing the design part, the next phase is the coding part. So here in the coding part, the coding is done, and after doing the coding, testing is done. So whether the code that has been created, that is working correctly or not. So everything is tested in case of testing phase, and after the testing phase, the next phase is the implementation phase. So here the complete product is created. Okay, and after creating the complete product, the next one is review. Review means the product will be provided to the customer. So based on the feedback will be got from the customer. Based on the customer feedback, if there are any changes that has to be made, means what is going to happen is, again we are going to do the next iteration. That one we are calling it as iteration 2. Iteration 1 is over. So we have got the requirement of the customer, then analysis is done, design is done, and after that coding is done, then it is tested, and after doing the testing, the complete product is created, and after creating the complete product, it is provided to the customer and the feedback is got. If the customer has any query, then what happens is, again we are going to do the design. Based on the customer feedback, we are going to do the design again. So next we are going to do the design means, so that is called as iteration 2. So again the same process is repeated again. So that is why it is called as iteration. So the designing is done. After doing the designing, coding is done. So and after doing the coding, it is tested whether the product is working correctly or not. So it is tested. Implementation, again the complete product is created, and again it is provided to the customer. Still, if the customer is not satisfied with the product, and if he has any feedback, then what happens is, based on the customer feedback, again we are moving on to iteration 3. So again we are doing the phases again and again. So again we are doing the design part, and after that coding is done, and after doing the coding, it is tested whether it is working correctly or not. So that one is tested, and after that we are doing the implementation. The complete product is created, and after doing the implementation, review is done. Review is nothing but we are getting the feedback from the customer whether it is working, whether the customer is satisfied with the product. So the review is got from the customer, and after doing the review, deployment phase. Deployment phase means it is given to the customer. So we have created the entire product, and the customer is also satisfied, and it is provided to the customer. So that is called as the deployment phase, and the next one is the maintenance. So this is going to be the last phase. So if there are any maintenance issues, means it can be solved in the maintenance phase. So these are about the iterative model. So we have many iterations over here. And the next one is, let us see the features in the iterative model. So here the first and most important feature is changing requirement. So already I told that in case of waterfall model, the requirement cannot be changed. It is a fixed requirement, but it is just the opposite of the waterfall model. So here you can change the requirement. So that is why we have many iterations over here. And the next one is, it can be used in case of large project. So waterfall model can be used in case of small project. This iterative model can be used in case of large project. Next one is customer feedback. So here often we are getting the feedback from the customer, and based on the feedback we are changing the design, and again we are providing that to the customer. So these are all the features of iterative model. Next one is disadvantage. So what are all the disadvantages in this iterative model is, here we need more number of resources, and the deadline is not confirmed. So we are doing many iterations, so it is taking more amount of time. So the deadline is not confirmed in case of the iterative model. And the next one is over budget. So obviously if we are doing the same task again and again, means definitely the budget will be high. So that is one of the disadvantages in this iterative model. So this is about the iterative model. So the next model what we are going to see is incremental process model. So what is main about the incremental process model is, first the requirement is got from the customer. So after getting the requirement is freezed. So we cannot make further any changes in the requirement. So after freezing the requirement, what is going to happen is we are going to split into various modules. If we take a software, entire software, so we are splitting that software into various modules. For example, consider this to be module 1 and then module 2 and then module 3. So totally we have 3 modules in this project. So we are getting the requirement from the customer, and after getting the requirement we are freezing the requirement so that we cannot make any changes further. We cannot make any changes in the requirement, and the requirement we are splitting it into various modules. So we are going to perform, and after this we are going to do the design part, then implementation, testing, everything we are going to do, but the requirement we cannot make any change. So we are freezing that. And in module 1, so if we take module 1, the first part, if we take, so what we will be doing is we will be doing the designing and then development. Development is nothing but testing. So designing means we will be creating the diagrammatic format, and after that we are doing the development. So here we are doing the creating the coding. After doing the design and development, we are moving on to the testing phase. So again we are checking whether the module 1 is working correctly or not, whether module 1 is executed properly or not. So that one is tested, and the next one is we are doing the implementation. So the product, complete product about module 1, not the entire software, only module 1 is complete module 1 is created. So that is what we are calling it as the implementation. So module 1 is over, the next one is module 2. So here again we are doing the same process. We are doing the design and development. That is nothing but creating a diagrammatic representation and then creating a coding part. So this one is done, and then testing is done for module 2, and after that we are creating the product for module 2. And then we have one more module, that is module 3. So here what happens is the same process is repeated again. We are doing the design and development, that is nothing but diagrammatic format and then coding, and after doing this we are doing the testing whether module 3 is working correctly or not. So that one is tested, and then the complete product about module 3, that one is created. So what happens here is we are implementing all the modules separately, and at last it will be combined together. So what happens in this case is the timing will be reduced. So simultaneously all the modules are done at the same time. So at the time module 1 is created, so this at the same time module 2 and module 3, both the modules are created at the same time. So when everything happens at the same time, so definitely the project can be done at a lesser amount of time. So this is one of the greatest advantage of the incremental process model. So let us see the features. Fixed requirement. So what we are doing here, we are getting the requirement from the customer and we are freezing the requirement. Freezing in the sense we cannot make any changes in the requirement. So that is called as a fixed requirement, and then it is used in large projects. So that is why we are splitting into various modules. So we are splitting into various modules and we can use it for large projects. Next one is quick release. Quick release means, see, we are doing all the process simultaneously at the same time, so we can deliver it to the customer in a lesser amount of time. So that is called as quick release. Next one is easy to recognize error. Instead of creating the entire project and then finding out whether there is any fault, so if we find out the fault by creating the module separately means, so it will be easy. So that is called as easy to recognize error. The next we shall see about the disadvantage. So the first disadvantage is here you need more number of resources. Okay, more resources are required. So we are doing many modules simultaneously at the same time. So here we need more number of resources and we need a good team, and proper planning is required. Only when the team is good, so when all the modules are created at the same time and if it is planned accordingly, so everything can be done on the right time. The next model what we are going to see is the spiral model. So if you see the diagram itself, it is in the form of spiral representation. So that is why this model is called as the spiral model. So also this model comes under the category of iterative model. So the same thing is repeated again and again. So if you are doing some steps, means the same steps are repeated again and again. So that is why it is called as spiral model. Also it comes under the category of iterative model. So if you take the spiral model, we can divide the spiral model into 4 parts. Number 1, the first phase is planning, and the second phase is risk analysis, the third phase is engineering and execution, and the fourth phase is evaluation. So these are the 4 phases in the spiral model. So what happens in the planning phase is the requirement and then analysis. So both the things takes place in case of planning phase, and then in the phase called as risk analysis, the prototype is created, and in the next engineering and execution phase, development and then testing is done, and in the fourth phase, evaluation phase, the customer evaluation is done. So let us see this deeply. First one is planning phase. So first what happens is, as we see in all the other models, first the requirement is got from the customer. So whatever is the need of the customer, so that requirement is got from the customer, and after collecting the requirement, the analysis is done whether that project can be done without any issue. So those analysis is done after collecting the requirement from the customer, and after doing the analysis phase, what we are doing is we are creating a prototype. So this happens in case of the risk analysis phase. So we are creating a prototype, and after creating the prototype, what we are doing is we are doing the development. Development means here we are doing the coding, and after that we are doing the testing. So whether what you have created is working or not. So we have done the testing, and after doing the testing, the evaluation is done by the customer. Whether it is the customer is satisfied with the product what you have created, so that evaluation is done by the customer. So if the customer is not satisfied, means what we are going to do is we are going to repeat all the 4 steps again. So we are going to get the requirement. So what is the change in the requirement? So that one we are going to get from the customer, and after that analysis is done, and after doing the analysis we are moving on to the next phase, prototype. So here the prototype is created, and after that again we are doing the coding, and again we are doing the testing for the code you have created, and after that the evaluation is given to the customer, whether the customer is satisfied with the product. So if the customer is satisfied, means we can stop here. But still, if the customer is not satisfied with the product that has been created, means again the same steps are repeated. So the requirement is got from the customer, and then analysis done, prototype is created, and then development, coding is done, and testing is done, and then evaluation. The next phase is going to be the evaluation. If the customer is satisfied, we can stop here. So the same process happens in the form of a cycle till the customer gets satisfied. The same thing is repeated again and again until the customer is satisfied with the product that has been created. So this model is called as the spiral model. So let us see the features. So here what we are going to do is we are going to identify the risk and then analyze the risk. So this we won't be doing in other models, but here we will be identifying the risk and then we will be doing the analysis of the risk, and after that we can have the feedback from the customer. Okay, so based on the customer feedback we are creating again and again. So that is called as the customer feedback, and here we are using the prototype. So that is one of the feature. And then disadvantage. Disadvantage, it is unclear. So the customer is keep on changing the requirement, so he is unclear about the requirement. Next one is complex. So we have created a model and again we are making some modification in the model. So it is complex, to change it again and again it becomes a complex job. And then excess budget. So we are doing the same process and again, so the budget is more in case of the spiral model. So this is about the spiral model.